Hey everyone, this is the first video of an entire series focusing on introduction to programming that covers topics from programming fundamentals to data structures and algorithms. So without any further ado, let's get started. So first of all, let's talk about what is programming. In simple terms, attempting to get a computer to complete a specific task without making mistakes. In other words, we can say it is a way through which we communicate with the computer to accomplish a certain task. We do that by giving the computer a set of instructions to be executed in order to achieve the goal of completing the task. So with that being said, let's move on to the types of programming languages, or more specifically, types of programming languages based on the way in which we communicate with computers. Computers can only understand binary code, that is zeros and ones, which is also known as machine code. But humans can't understand machine code. Therefore, programming languages are used as a medium to communicate with computers. Now let's talk about the types of languages in detail. First, we have assembly languages. It is any low-level language in which there is a strong relationship between the instructions of the language and the machine code instructions. For example, the instruction move A, B means save the content of B into A register. So what are registers? Registers are small storage locations in the central processing unit which are used for faster access while performing various operations. Now the assembly code is ready. Now this assembly code is to be converted into machine understandable code. So the assembly code is converted into executable machine code by a program referred to as an assembler. It was becoming very difficult to work with assembly code because it was long and tedious to write. It was very difficult to find bugs and fairly difficult to maintain the code too. Also, assembly code written for one architecture was not portable to another, so they were CPU architecture dependent. Hence, high-level programming languages were invented. High-level programming languages are easier to use, and they also make the process of developing a program far simpler and more understandable than when using a low-level language. Some of the popular high-level programming languages are Java, C++, Python, JavaScript, etc. Now let's talk about the types of programming languages based on the way in which they are designed. So first we have procedural languages. It is the programming model based upon the concept of calling procedures. Procedures are also known as routines or functions, simply consist of a series of computational instructions to be carried out. During a program's execution, any given procedure might be called at any given point. Some examples include Fortran, COBOL, C, etc. Next up, we have functional programming languages. These languages use an approach to problem solving that treats every computation as a mathematical function. Some examples include JavaScript, Python, Scala, etc. The third and final type of programming languages are called object-oriented programming languages. Object-oriented programming is a programming paradigm based on the concept of objects. Objects are real-world entities that have state and behavior. States are called attributes or data members. Behaviors are called as methods or member functions. We will look into detail on object-oriented programming in a separate video. So some examples of object-oriented programming languages include Python, C++, Java, JavaScript, PHP, etc. As you might have noticed, one language could fall into multiple categories. For example, Python is procedural, functional, and object-oriented, and JavaScript is functional and object-oriented. Therefore, it's not necessary that one language must belong to a single category. So with that being said, let us move on to a much more important topic, which is memory management. So memory management is done using stack and heap memory. So first of all, let's talk about stack memory. The allocation happens on contiguous blocks of memory. The size of the memory to be allocated is known to the compiler, and whenever a function is called, its variables get memory allocated on the stack, and whenever the function call is over, the memory for the variables is deallocated. We will see in detail about functions in a separate video. For now, consider it to be a block of statements that perform a task. So now that stack memory is clear, let's move on to talk about heap memory. Memory is allocated during execution of instructions written by programmers. This is called heap because it is a pile of memory space available for allocation and deallocation. Whenever we create an object, it always gets space allocated in heap memory, and the referencing information to these objects are stored in stack memory. Now, what does that mean? Let us look at this in detail with an example. So consider the example shown here. So irrespective of the programming language, consider we have two variables, s and str. So s is a variable that stores a string of characters. Here we have hello. And str is another variable which has a copy of s. That is, the content of s is also there in str. So it is a copy of s. So also you can see that we have stack and heap memories shown in the diagram on the left hand side and right hand side respectively. So you can see that we have str and s on the stack. So the memory address of value hello, that is 5000, is stored in these locations. And the actual value, which is hello, is at the address location 5000 in the heap. So these two variables, str and s, are reference variables which refer to this particular address location 5000, which contains the value hello. Let us move on to the key differences between stack and heap memory. In a stack, the allocation and deallocation are automatically done by the compiler, whereas in heap, it needs to be done by the programmer manually. Processing of heap memory is quite slow as compared to stack memory. Now that is very evident from the next point, that is, stack memory has less storage as compared to heap memory. Therefore, the processing is also quite fast in stack memory as compared to heap memory. So with that being said, let's move on to the final topic of today's session, which is garbage collection. So it is a form of automatic memory management. It relieves the programmer from performing manual memory management, where the programmer specifies what objects to deallocate and return to the memory system and when to do so. In C or C++, programmer is responsible for both creation and destruction of objects. Sometimes programmer neglects destruction of useless objects. So what happens as a result of that? So when new objects are created, sufficient memory may not be available and the entire program will terminate abnormally, causing out of memory errors. But in Java, garbage collector takes care of these things. We will learn more about that in the upcoming videos. Now that we have understood the fundamentals of programming and languages, we will deep dive further into other concepts in the upcoming videos. Hey everyone, in this video we are going to talk about flow of a program, and more specifically about algorithms, flowcharts, and pseudocode. This is the second video of the series, Introduction to Programming, that covers topics from programming fundamentals to data structures and algorithms. In the last video, we talked about types of languages and memory management. So without any further ado, let's get started. So first of all, let's talk about algorithms. What is an algorithm? An algorithm is a finite sequence of well-defined instructions used to solve a specific problem or perform a computation. Next, what are the characteristics of an algorithm? An algorithm must be clear and unambiguous. That means each of its steps should be clear in all aspects and must lead to only one meaning. Well-defined input. If an algorithm says to take inputs, it should be well-defined inputs. Well-defined output. The algorithm must clearly define what output will be yielded, and it should be well-defined as well. Finiteness. The algorithm must be finite, that is, it should not end up in infinite loops or the like. Feasible. The algorithm must be simple, generic, and practical, such that it can be executed using the available resources. And finally, and most importantly, it should be language independent. That is, it must be plain instructions that can be implemented in any language, and yet the output will be same as expected. Now, we have understood the characteristics. Let's move on to talk about how we design an algorithm. In order to write an algorithm, the following things are the prerequisites: the problem that is to be solved with the algorithm, the constraints of the problem that must be considered, the input to be taken to solve the problem, the output to be expected when the problem is solved, the solution to the problem according to the given constraints. So with this, let's look at an example. Let's look at an algorithm to add two numbers. So first we declare two integer variables num1 and num2. So we are taking two numbers as input from the user and we are storing those values in num1 and num2 respectively. Declare an integer variable sum to store the resultant sum of the two numbers. So and then we are adding these two numbers and storing the result in the variable sum. And finally print sum. And that will be the end of this algorithm. So with this, let's move on to the next one, which is an algorithm to find largest among three numbers. So first we declare three integer variables num1, num2 and num3. So we take three numbers as input from the user in this case, and we will store them in num1, num2 and num3 respectively. And then we will move on to checking the conditions. So first, if num1 is greater than num2, if this condition is true, we will check if num1 is greater than num3 also. So if that is also true, we will print num1, otherwise print num3. Suppose if num1 is greater than num2, if that condition is false, then we will check if num2 is greater than num3. If that is true, we will print num2, otherwise we will print num3. And that will be the end of this algorithm. So now let's look at this example 2 with an explanation. Here in this case, we have three numbers as input from the user. They are 12, 1 and 33. So first we will start and we are declaring three variables num1, num2 and num3. And then we are taking three numbers as input from the user, which is 12, 1 and 33, and we are storing these values in num1, num2 and num3 respectively. And then we are checking if num1 is greater than num2, that is if 12 is greater than 1, which is true. And then we are checking if num1 is greater than num3, that is if 12 is greater than 33, which is false. Hence we are printing 33, which is the largest among these three numbers. And that will be the end of this algorithm. So now that we have talked about algorithms, let's talk about flowcharts next. So what is a flowchart? A flowchart is a graphical representation of an algorithm. It uses various symbols to show the operations and decisions to be followed in a program. The common symbols that are used in building a flowchart are as shown below. So we have start or stop, input, output, processing, condition, and the corresponding symbols are shown on the right side. So let's look at an example of a flowchart in which the aim is to add two numbers. So first we will declare three variables, num1, num2 and sum. And then we will read two numbers as input from the user and store them in num1 and num2. And then we will add these two values and then store the sum in the sum variable. And then finally we will display the sum, and that will be the end of this flowchart. Now as an example 2, let's consider finding the largest among three numbers. So first we will declare variables num1, num2 and num3. We will read three numbers as input from the users and store them in num1, num2 and num3. And then first we will check if num1 is greater than num2. If this condition is true, we will check another condition num1 is greater than num3. If this is also true, we will print num1, otherwise we will print num3. So if the condition num1 greater than num2 is false, then we will check another condition which is num2 is greater than num3. So if this becomes true, we will print num2, otherwise we will print num3. And that will be the end of this flowchart. So now that we have talked about flowcharts and algorithms, now let's talk about pseudocode. So what is a pseudocode? It is used to represent the implementation of an algorithm. And also it can be interpreted irrespective of the programming background. It has no syntax like any of the programming language and thus can't be compiled or interpreted by the computer. As an example, let's take sum of two numbers. So the pseudocode would look something like this. So first we will start, input num1, num2, sum equals num1 plus num2, and finally printing the sum, and that will be the end of this code. As a second example, we have finding the largest among three numbers. So we will start, input num1, num2, num3, and we will start checking the conditions. If num1 is greater than num2, if num1 is greater than num3, then print num1. Otherwise, print num3. If num1 is greater than num2, if that condition is false, then we will move on to the else part and check another condition, which is if num2 is greater than num3, then we will print num2, otherwise we will print num3. So this will be the end of this pseudocode. Now that we have understood the flow of a program, we will deep dive into other core concepts in the upcoming videos. So with this, let's wrap up today's session. As always, thank you so much for watching. Please like and share, and don't forget to subscribe to the channel. With that being said, I will see you in the next one.